So let's start. If you're looking at page 474, you see this table with your generation and population, and you see it in this graph over here. So it's essentially these coordinate points plotted in comparison to each other. So we would, just by looking at this, we could say, hey, there's probably some line of best fit that goes approximately in that angle. My guess is it actually doesn't go through the origin, unlike my line shows, but anyway, just by looking at it, right, we can kind of identify what that is. So let's back up just a little bit. We've got to find the average population size. And so this here, I think it's shown, yeah, it's in your book. Y'all, this is just how to find the average. All of this crazy stuff, you know how to find the average of something, the mean, right? And it's that little line on top here. And this basically says, hey, add up all of your values and then divide it by the number of numbers. That is just finding the average of something, and you've done that so many times. And this here is the sigma, which represents the sum of all numbers from when I equals 1, okay? And so this is our first value. All right, so it's just like really crazy language to say. Let's add them all up. So let's see what numbers we have. We have 1 plus 3 plus 2 plus 3 plus 5 plus 4 plus 5. And how many numbers do we have? Well, they conveniently are counted for us here, but otherwise we would just count them up. So we would divide that by 7, right? Finding the average of all this. That gives me 23 sevens, or approximately 3.29. All right, so approximately 3.2 or 2.29 is the number we could predict the number of bacteria after a given generation. So we would say, here's my average between all of those. All right. So why is that even helpful? Well, we know that the average, and I'm just going to rewrite it this way, and I guess I should say approximately 3.29. Okay, we can really say that it is equal to it for our purposes here, but you know that technically it's just an average and it's rounded. We're going to find that this is going to be halfway through. So if you look, I don't know, 3.29, let's erase this other line that we have here. So it's probably going to be right about here. If we were to say, hey, y equals, I guess we should make this an equals in terms of a line, right? Horizontal line. Has no x value, no slope. So do you see how about half the data is on top and half is on the bottom in terms of distance from that line? Well, that's because it's the average, okay? So suppose that we want to actually create our line of best fit. Well, we recognize that our correlation is going upwards, and we recognize that it can't just be this equation right here. Like, it's not a horizontal line. It's got to be... see if I can erase this while I'm talking. It's got to be, the correlation pulls it upward, right? So what we want to have here, I'm going to zoom in on my picture. We want to have a line of best fit. And I'm going to draw what I think is approximately it. This is not really accurate, okay? Obviously, there are more numbers or more points below. This is a bad one. Let's see. There are more points below, but they are closer to the line. Okay, makes sense? So here we have some linear equation, and a linear equation can be defined as y equals mx plus b. I mean, that goes back to pre-algebra, right? That's an equation of my line. Well, we are going to understand that we could also have my y could, well, let's get to that in a minute. Our y can represent our average or our mean. Okay, so I'm going to switch colors here. And essentially, the whole point is if we were to take the method of least squares, we're finding, and you actually have to use calculus to find a deviation and a couple other things, which we're not going to fully get into. But what we want to identify is every point has a certain distance to my line of best fit. Okay? Now you'll notice some of these are longer than the others. And now a distance is, you know, if you think distance, we think absolute value, right? Or you should, right? The absolute value of some distance right? You can't have a negative distance. You can't go to the school and walk backwards. So you have direction, right? Kind of like a vector in a way. But so we're going to need to use absolute value, because what we want to say is this distance here, and this distance here, and this distance here, and all of these distances, we have some that are above and some that are below. And so we want to say that this line falls exactly in between all of these distances. If I were to add them up and divide by them, would give me my average, or my, right, 3.29 in this case. And so I think in your book it shows these deviations are going to be the absolute value. Let me kind of erase some of this here. Okay, so it's going to be the absolute value of y subscript I minus, and they use this hi-hat symbol here, essentially saying just the distances above and the distances below, and then subtract the two and take the absolute value of it. Make sense? We want the least amount of difference. Ideally, this is 0. Okay? In the perfect world, that sum of the deviations is going to need to be 0. I'm going to say if this is a positive, it's not really a whole one, but let's say that's 1 and that's 1, and then like let's say that's a fourth, and this is a fourth, and I'm technically these would be negative, right? They're going below, but I'm going to just apply that distance already. And a half, those look about a half. So on this side we have 2, right? If we were to add those up, the sum of those distances, and down here a fourth, and a half, that gives me, that's not quite there. So 1 3/4. I want those to be the same so that when I have the differences as close to 0. Do you remember that from before when we, I think there was one of the questions where we had to try to find it was within the bell curve. No, it wasn't quite in bell curve. We were wanting to find the let's see, standard deviations. I think it was number 4. Caleb, I think we kind of talked about this one in particular, if you're listening. Number 4 on page 456. We talked about how we want the difference of those to be 0. In a real imperfect world, we're going to prove that those deviations are 0, or the difference between the deviations is 0, because we want it to be perfect. We want the same amount on the top and the same amount on the bottom. Now, because of rounding, it doesn't always equal that, but in this case, I'm estimating, so it's not perfect, but if you have a line of best fit, it will be exactly 0. The whole point is that you have calculated it so that it will be equal to 0. So I need 2 distances above, 2 distances below, or whatever your number might be. Now, we know that the sum of the squared deviations, or the differences there, if I were to square them, remember squaring is another way to get rid of any negatives. There's a way you can do that without using the absolute value. So the sum of the squared of those deviations is going to represent the error that you have, and again, you want it to be 0, and we're going to call that SSE. Let me zoom out here a little bit. We're going to call that SSE. All right. And so it stands for the sum of squares error. So we are going to set up a formula, and it's going to look really crazy. This is on page 475 if you're following along. Basically, all it's getting at is, hey guys, I want there to be as little error as possible. Okay? So that my line of best fit can be as perfect as possible. So we're going to have another sigma here. And we'll start at 1. Okay, and I want you to recognize this here as the deviations, right? This is the number, the distance on above the line and the distance below the line. And we're going to square it so that we don't actually have to do the absolute value. Okay, so let's see here. So I'm trying to find everything here. All right, we could finish this out a little bit here with our calculus, we're going to say that the SSE is the sum for all values of n when I starts at 1. And if I were to square that through, I'm going to get y I minus m xi minus b squared. Okay, so we're going to complete the square in a few different ways. This formula, we don't need to necessarily know where it comes from, but what I want us to recognize is that we can come up with a line of best fit. You're going to start seeing, I'm not going to go through the whole proof because there's calculus involved with this, but when we walk through what happens, we want to find in an easy way the distance above and the distance below the line. We want to get that to 0 so that our line of best fit can be as close as possible, exactly where we need it to be. So we're going to have a couple different calculations that we can use. We're going to eventually determine that we can sum up the squared values for x and for y values separately. So essentially what they're doing is they're saying, hey, I'm just going to create this into a little square because I squared it. So we're now going to have an x value and a y value because we have some distance vertically and horizontally. All right, so let's just kind of keep going. I'm going to give you most of the equations here. We are going to have the sum of squared deviation for x written this way. And it is sigma, or the sum of the change in x. Okay, and you'll recognize here that that x represents the average there. We can have some value of y. Again, don't fully need to know where these all come from. How to use them is going to be what's more important. And again, most of this, your calculator does all of it. We should kind of want to have an idea where it comes from. And then we're also going to have a third value. It's going to be called SS with a subscript SY or XY. I'm so sorry that my writing on a tablet abilities are really messy. You guys even see how messy I am on the whiteboard a lot of the time, but this is definitely exasperated here a little bit. Okay, so let's give some more room. Really, really fancy way to say that we can add these squares together. This means to add, right? Okay, we can add all of these squares together, and because some are positive, some are negative, even though we kind of got rid of that, the distances, when we find the average, all of that, if that comes out to 0, right, we have the same amount of distance above and below, then we've got our line of best fit. So we are going to have a formula to say that our slope of that line, and this is why we found all of these things. Here's the meat and potatoes of it all. The slope of that line, right, for y equals mx plus b, for a linear regression, is going to be written this way. Okay, that should be an equal sign. Once you find the sum of the squared deviations for x, y, you can divide it by the sum of the squares for x, and that will give you your slope. And then your y-intercept, I guess I can delete this part here. Your y-intercept, or your b value, is going to be equal to y minus mx. I mean, think about that. Y equals mx plus b. We can just rewrite that, right? We can switch some of the sides that this is on. And because we have the average there, we're going to write my symbol this way. All right. So that, sorry, I'm trying to change color. I'm not good at multitasking. Okay, so here are my two equations. If all of that was confusing, here are my two equations. This is what you mostly need to get at. Now, these values, as crazy as they may seem, and how are we supposed to find those and solve those are most likely going to be given to you. Okay, so if we were to jump ahead a little bit, looking at your homework, you are given SS subscript X and Y. And you just show those representations and have an understanding of what they mean. But that's about it. All right. Now, again, the goal is that this whole thing up here, the SSE, you want your error to be equal to 0. All right. In an ideal world. Now, is it always equal to 0? No, because it's not a perfect theory here. We want the error to be 0, but sometimes there is some error to our line if we haven't created it perfectly, and if we're given a line, we have to determine, is it really the best line? It's possible you could say, hey, here's a line. Is it the perfect line? Well, if your SSE isn't 0, then it's not, but it might be really close. It might be good enough for what you're looking at. Got to consider all of those things too. So, all right, I know this is turning long. I'm sorry. Using those two equations, we're going to practice one, but the other thing, we just need to be able to find our correlation. So correlation is how close are all of those points together, right? How much do they fall? If every single point fell exactly on the line, you'd have a correlation of 1. It would be perfect correlation. So our correlation is represented by an R, and it's going to be given by this formula. I mean, I should kind of make this a little bit bigger for you. Again, some of these values are given to you. All right, now we need the square root under here, and all of this kind of comes from needing everything to become positive, and this is your other formula. Okay, so you can find these in your book too, but those 3 formulas are the ones that you need. Remember, the coefficient of determination is what it's called in the book, is just the square of it. And without getting into all of that, I think you guys have done that a lot with correlations before, using R squared. That gets rid of the negative symbol. Again, you could have a negative correlation if the points are all coming down, or a positive correlation of it going up, and when you square it, it can eliminate that, and you can identify some more properties of the actual correlation without dealing with the negatives. So that's what that all comes from. All right, so if I do R squared, then I have one other, I guess this is still a related formula, but let me give you this formula also. I know I kind of lied. Told you that was the only one you needed. It might be helpful to use this. Again, they're all related to each other here, but this is in terms of SSE. Okay. Here is your other formula that we're going to use. Okay. Got those 4 formulas. Again, this R1 is most important, and finding your slope is going to be also important. Do you guys remember the formula for slope? I know we had it on another page. Hopefully you wrote it down. You probably start to be able to remember and identify these, but that way we just have it in one spot. All right. All of that feels a little crazy, so let's get to practicing one. All right. The one I'm going to go over with you, we are actually going to find some of the squares, and mostly you won't have to do that on your own. It's going to be given to you, but just so you have an experience, right? Okay, so if I had a chart of data, I'm actually going to... All right, so here are some x and y values. My first question is, what's the average of your x values and what's the average of your y values? Now we could write this out with the sigma. I'm just going to add them up and divide by the number of numbers, which is always going to be 5. So in this case, let's see, that gives me 23 divided by 5. And all my y values are going to add up to 30. Okay, now I'm going to represent these in decimals. We'll be using that. This is 4.6 and 6 equally or evenly, I guess. All right, so there we go. Not so bad. Just to find my means, right? You've done that many times. My next question is going to be, can I find the sum of the squares? Okay, so remember this one we need to have a little bit more information. So this one's going to be a little bit more work. I have to summate all 5 of these values. I'm just going to put a 5 up there, okay? X sub I minus the average of them here, and then we're going to square them. All right? So let's kind of create a table. To find the differences. All right. Now this should be review. If you were to just have x and if you had the mean of x, we could go back through here. We found the mean to be 4.6. So if you found the difference between the two of those, we would have a negative number, right? All right, so here we had 3. This is always going to be 4.6. In this case, it's still be negative 1.6. All right, can't remember all the values. 4, 6, and 8 here. Okay. All right, so now I'm going to be moving up into the positives here soon. So this is 1.4 and 3.4. Okay, now could I square that? Right? Isn't this what I want here? And then I'm going to find the sum of them. Right? This is the sum of all of this column. All right, so if I'm going to square this, I already did these earlier, so I'm just going to kind of jump up, throw them up here. Of course, you could use your calculator for this. All right, so I just squared these numbers, right? Meaning all of them will be positive. Now, in the past, you found a total column. And if you add them all up, we would get 23.2. This value here, my total, is my sum of the squares. All right? Again, this is sigma, meaning to add them all up. The squared of the difference between those two. So lots of steps, but no crazy math to it. Just a lot of steps to it. Okay? All right. Now I have to do that again for y. I'm going to use a different color here for y. We'll do the exact same thing. Now we already found the average, and that was 6. So let's see, I'm going to write my values down while I can still see them. So then their differences are going to be a little bit more easy to calculate without the decimals. Turning into the negatives here, though. Okay, then let's square that. All right, guys, following the steps we're doing, taking our y value, then we found the average of it, and then we subtracted their differences, and now we're going to square that. So what does that give me? 16, 4, 0, 1, and 25. Okay, now remember, I need the sum of that. Okay, so I'm just going to continue to show you what this notation looks like, but mathematically it's not much. All right, so let's see, if I added all these up, my total gives me, that's 20, 25, 46, right? Okay, so now I could just more simply say my sum of my squares value. Oops, 0.2, I guess. Okay. Now, again, you are going to be given those. I'm not going to quiz you a whole lot on that right now. All right, now, what if I asked for our other piece of information that might be most useful to us? Let's see if I can find some space here. Okay, so the other thing that we're going to need is the sum of the squares for x, y. Okay, and remember, based on our formula, that we said it's the sum of those values, which we already calculated a lot of this. These are steps that are building on each other, even though it looks like a lot each time. Look, I already found this part right here, right? That's why writing it out as a table and not just leaving it in your calculator, is helpful, because then you can look back and see what those values were. Because these are our values that are not squared, okay? So this column right here, I'm sorry, this section, you can't see it, this section right here, and this section right here are already in my table from below. This column here, right, the difference, and this column right here. And then, based on my formula, because they're shown in parentheses, I'm going to need to multiply those together, then I can add them up. Okay, so I'm going to make another table. And I am just going to literally copy this and this from the from what's below. Okay, so I'm going to pause that and it'll just kind of pop up for you. All right, so I just copied these from my chart, okay? Both your x and your y's. And then in this column, this is our new column, we're going to multiply the two of them. So negative 2.6 times 4 gives me negative 10.4. And again, I'm just recognizing I need to do that from this portion of my formula. Now, this means that I need to say, hey, I'm going to add up all 5 of them. Okay, and there should be a little 1 right here. Okay. All right, so then here are all my numbers, and I'm just going to add them up. That is all that you have to do. Again, the math is really not hard. It's just interpreting the symbols and understanding where it comes from. So I could say, so I have these 2 numbers here in yellow, and I could say the sum of the squares of x, y is negative 32. Okay? So there is, let's see if I can move this. Okay, here are the 3 pieces of information that are going to be really important. Now that I have those 3, I can now find the slope of the line, the b-intercept, and therefore, if I have both of those, the equation of the line. All right, so let's get a new page and kind of roll with this a little bit. In order to find the slope of the line, hopefully you remember the equation. I'm just going to take these numbers and plug them in. So I just found the sum of the squares for x, y, and that is negative 32. So that's my numerator. And my denominator is, let's come back here, 23.2. All right. Now, just calculate that and find an approximation for your slope. Technically, I suppose this should be approximate. That's going to be negative 1.38. for my slope, okay? Now, again, if you're finding an equation of a linear line, you need both your slope and your b value or your y-intercept, all right? And in this case, we have the average of y minus the slope times the average of x, okay? And that, again, comes from all our points and kind of finding the averages between them. You could have a, well, we don't need to get into that, but you could have a straight line and a horizontal line, and we did the horizontal line a little bit there. Okay, so we are going to then say, all you guys just plug them in, right? So the average here was of y was 6, if I remember right. Oops. Yeah, all right. And minus my slope, negative 1.38. Just be careful when you're subtracting a negative. That's an easy spot to make a mistake. And then I think it was 4.6. That's my other average. I added that enough times, right, to remember. All right, so, wow, really all we have to do is just kind of calculate that. And I don't really have to use the approximate symbol, although technically I have some things rounded, so I'll take either one. And especially on the computer, you're not really going to be able to do that, so I'll just take your number. Okay, now that I have my slope and I have a value of b, now it's just really simple, right? Just find your equation. So y equals negative 1.38x, plugging this in, and y equals mx plus b. That's where this is coming from. Now I have my slope and I have my b value. It's going to be plus 12.35. Okay, so there you have it. All of that work to find the equation of the line of best fit for the given points in this here table. All right, so I kind of will put it all in one spot here. If you were to plot those points, and then if you were to write this line, or draw the line in that same coordinate plane, it would be the line of best fit for those points, and you could check that in your calculator. All right, so correlation is how related are these points to each other. Now, if we were to plot all of these points, we would see, I mean, you can look, your x values are going up and your y values are going down. So that means that my line is going kind of like this, right? I guess this should be, they're going up that way. Okay. So I'm guessing that I'm going to have a negative correlation just because I'm recognizing where my points would be. If you were to stop and plot all of them, you would see they kind of would go a little bit kind of like this, okay, in the negative direction. I also, actually, maybe I should just kind of plot a couple of them here. Let's just see what that's like. Again, this is not going to be awesome because I am doing this on a tablet and there is not much accuracy to this. I could import a picture. I suppose I should have done that. Okay, so 2 and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here's my first point. 3 and 8. 4 and 6. 6 should be there. All right, and then I have 6. 1, 2, 3, 4, 5, 6, and 5. 1, 2, 3, 4, 5. And 8. 1, 2, 3, 4, 5, 6, 7, 8. Sorry, I should have done this while you guys paused it. Okay, so if I'm noticing, I was right in the sense they're all coming down, but they're really close to each other, aren't they? Now, they're not in a perfect line. It's not a direct correlation. It's not a perfect correlation. But I'm guessing this is going to be pretty close to a -1 then. Okay, so a -1 would be a perfect negative correlation, and a +1 would be a positive correlation where every single dot was exactly on the line. And the closer to 0 any of those numbers are, the less correlated. So if you had like a -0.02, then your dots are probably pretty far away from your line. Does that make sense what the correlation is? Hopefully that's review, but I want to just kind of touch on that. Okay, so correlation. We need to pull out our correlation formula. So I'm going to kind of come over here. Oops. All right, so here's my formula, and I'm just going to plug those numbers in. Again, when you have to do this and you already have the formulas, y'all, it's going to be so simple. Or, I'm sorry, you already have the hardest part is just finding the sum of the squares. All right. So that's, now I need to take the square root of the sum of the squares for x. I think that was 23.2 and 46. And I'm just going to multiply those together because they're right next to each other, signifying multiplication. All right. Multiply those together, then take the square root, put it in the denominator, divide -32 by that number. I'm plugging that all into the calculator. It should follow those order of operations. Now I see that I'm going to have a positive number in the denominator and a negative number in the numerator. So I already know it's going to be negative, which is what I want it to be. I guess that's about -0.98, which is close, really close to -1, isn't it? So that's my correlation. If I were to interpret that, I'm basically saying my best fit line is a negative slope and my points are really close to my line. If you were to have r squared, this is how you know the improvement value. So if you were to square that value of r, you would get a positive 0.96, which means there's a 96% improvement. It is 96% of the way close to being perfect. All right, that's really all it means. And we're not going to get into too much of that. We probably did that a lot in Algebra 2. So anyway, hopefully this video is a lot longer. I'm so sorry about that. I'm going to stop there. Hopefully you can find the information you need for homework tonight. You're already given those values. Number 9, you'll need to do what we just did. You're just going to take whatever your R value is and square it and say it improves on average by whatever that percentage is. And then tell me if it's positive or negative too, okay? So that's what that is for number 9. To find SSE for number 10, just use your formula. You're going to kind of have to look backwards. You know some of the information in our formula. You'll need to use this r squared. So this is number 9 here. Number 10 for homework, you'll need to do r squared is equal to the sum of the squares for y minus SSE. This is where you'll use this formula. Okay, so plug in this number here, this number here, this number here, and then just algebraically solve for SSE. Make sense? So please reach out to me if you have any questions. I know this might have been as clear as mud, but hopefully it was a little more fun. Missing you guys. Can't wait for our Zoom call. If you're wanting to try a couple more of these, you could try numbers 21 to 26 on your homework on page 478. I don't know if you can see that yellow or not, but just to had another piece of information, you could practice finding some of those values. All right, miss you guys. Talk to you later.